welcome back to Explore Electronics. In the previous video, we have already discussed the topics such as the form of a C program, library and linking, separate compilation, compiling a C program, and C's memory map. So, if you have not watched those yet, make sure to go back and watch them first, then continue with this video. It will help you to understand better. So, next, in this video, we are going to learn another important concept from your syllabus, that is chapter 3. The name of the chapter is expressions. Today, we are going to learn about these topics, the basic data types, modifying the basic types, identifier names, variables, and the 4C scopes. So, before we start, make sure you have your notebook and pen ready. Note down the key points as we go along. These notes will really help you during your exams and serve as a quick revision keynote later. Okay, now let us move on to today's concept. And the first concept is the basic types. Expressions are formed from these atomic elements, that is, data and operators. Both combines to form expressions. Data may be represented by variables, constants, and values written by functions. There are two versions. One is C89 and one is C99. C89 version has mainly five data types. That those are this character, int, float, double, and wide. Character type is nothing but A, B, C, like this. It goes on. Integer type, it include both negative number and positive numbers and including 0 2. And float and double, both are same. It includes decimal point values. For example, 0.24 like this. But the difference between these two are the size. Each one of sizes different and wide. That is valueless type. We can say this as empty. It don't store any values or it don't return any values. It is nothing but a void. These five types form the base for creating other data types like arrays, pointers, and structures. About this topic, you will be studying in the upcoming modules. Okay, next, size and range of data types can differ depending on the compiler and processor used. But char is always 1 byte in size. This is fixed for all compilers. Next is size of int. The size of char is 1 byte, that is remains same for all the compilers. When it comes to the size of int, here it depends on the system and also with the environment. For 16-bit system, that is 16 bits, that is nothing but 2 bytes when we tell in the form of bytes. And for 32-bit system, int is equal to 32 bits, that is 4 bytes. And this is all about the data types of C89 version. Now let us see the data types that was included in C99 version. They are bool, complex, and imaginary. Bool is nothing but only there are two what forms in it, that is true or false. When it comes to a complex, for complex numbers, imaginary numbers. Then floating point values depends on the implementation, either compiler and system, but the minimum range lies between 1E37 to 1E plus 37, and the precision also differ for float and double. Char variables as usually store ASCII characters. ASCII characters nothing but letters, digits, symbols, and values outside the ASCII range may behave differently on different compilers. It varies. Next is void type uses. Void, as I said earlier, void is nothing but empty. It does not return any value. We can say a function that returns no value. Example, void display. To create a generic pointer, how can we use void data type? Here is an example to show that. That is void asterisk pointer. In this way, we will use void in a pointer. About this detail you will be learning in the upcoming modules, that is about the pointer. Here you can see the basic data types in C. I have included one chart here. It is easy. You can, I will pause for 1 second. You can take a screenshot for this because it will be helpful to you to remember during your exams. Okay, chart, nothing but character, int, integer. Here meaning is given, means the full form. Here's the data type, means how you will be writing in a program. The typical size 1 byte to system 16 and 32 bits and 4 bytes, 8 bytes and no return functions or generate pointers. So take a screenshot and keep it as a reference for your memorization. Second concept is modifying the basic types. Type modifiers changes the meaning of a base type to suit a need. This is a definition. Look, there are totally four modifiers. The first one is signed, unsigned, long, and short. Which types can be modified then? They are int can be changed by signed, unsigned, long, and short. Char can be signed or unsigned, but long and short won't come here. Third one, double can be long or long double. That is long double. Both are same. And C99 also adds long for larger integers. Here it is not a repeated word. It is type. But while writing a program, we won't use this type much. Signed on integers is as usually redundant. It means exceeding what is needed or useful. Or to say in a one word, we can say as unnecessary, which is not required. Like that, continue. Because int is signed by default. Its most useful role is to explicitly make char signed on system where char defaults to unsigned. Here, signed versus unsigned. Signed integers, if it is 0, it means positive, 1 means negative. Unsigned integers interrupts all bit, means they cover large positive range. Ranges and sizes. C means C standard gives minimum guaranteed range, not exact size on all system. As the size varies on different system, that is 16-bit system and 32 one. And float, double, long double have a specified minimal precision and range. Here example is given. The minimum range of float is approximately 1e 37 to 1e plus 37, that is approximately a 6 digits precision. Means it the precision varies for differently. Means for float, double, and long double. Please take down these points and the highlighted one make it highlighted so it will be easy for you to understand and remember. Make down a points. In general, negative numbers are represented using two's complement approach. Now let us see what is this two's complement approach first. Okay, complement is nothing but ulta, making opposite thing. Now let us take an example here to make you easier. I'll take a only four-digit number. Let us say 0111. This is the given number. Now I'll do one's complement. That is for 0 I'll write it as 1, 1 0, 1 0 and 1 0. This is nothing but one's complement. Now how to do two's complement? It is easier, that is add 1 to this. When I do this, I'll get it as 0 plus 1, 1, 0, 0, 1. This is a two's complement of this number. I think you got it. Now which reverses the same thing had given, but here except the sign flag, we will apply or implement this two's complement approach. Now signed integers are important for great many algorithms, but they only have of the absolute magnitude or unsigned relative. Here example is given. For this, we can express this number in a binary form. If the higher order bit was set to 1, the number would be interpreted as -1. Okay, that is indicating a negative number. However, if you declare this to be unsigned int, the number becomes This one means 65,535 when the higher order bit is set to +1. Now, when a modifier is used by itself, when a type modifier is used by itself, that is, when it does not precede a basic type, then int is assumed. Means by default, if anything is not mentioned in the type, by default it is assumed as int type. Here you can see, for example, signed. It is same as signed int. While writing a program, if you mention or type the data type as signed, unsigned, long, short, only this, then the compiler assume it as signed means signed int, unsigned type, int as long int, short or short int. Both are same. By default, int is taken. Although the int is implied, it is common practice today to specify int anyway, right? If it is same also, we will mention int in our program to make us understand easily. Next, here you can, this is a table, all data types defined by a C standard, all in given in a one go, that is char, unsigned char, signed char. As I mentioned in the previous slide, char can be changed to unsigned and signed. Int both the four modifiers also it can be changed. Int, unsigned int, signed int, short int, and unsigned short int. Okay. Here you can modify into different ways also. They have included here float, double, and long double. Here the typical size in bits also mentioned and the minimal range. Okay, this is all about the data types defined by C standard. The next concept that is identifier names. Now let us see the definition of identifier first. An identifier is the name you give to the variables, function, labels and other user defined items in C. That's what is called as identifier. The first character of an identifier must be first character. It should be A to Z or underscore. And the subsequent characters means after the second character, it may be letters, digits, or underscore. It is acceptable. And main thing, identifiers are case sensitive. Here you can see the example count, count, count. The pronunciation or sound remains the same, but it is case sensitive means count, count, count. The compiler takes it as three different words, not the same, are three different identifiers. Now, in identifiers, we have two types, that is external names, internal names, or we can call it as external identifiers or internal identifiers. What is meant by external identifiers? Means external identifiers used in linking between source files. For example, global variables and function names that other files call. That's what external identifiers. Internal identifiers means used only with a single translational unit, means source file. Within a file, we will use the internal identifiers, means external files can't use the identifiers which is mentioned internally. For example, local variables inside functions. This is the example for internal identifiers. Now here you can see the correct form to write the identifiers. Count, one count, test 2, 3, hi there, high balance, high balance. These are all are correct and these are all incorrect. Why this is first one is incorrect? Can you guess? Yes, you are right. Means here count. It is correct. Here one count, as I said, the first character of an identifier must be letter. Means the identifier name should start with either letter nor or underscore, but not the digit. Here the identifier name starts with digit, so it is not considered. It is considered. And here in second one, hi there. Test 2, 3 is correct and I there is not considered, as you can see the exclamatory mark over here. As I said, the first character should be underscore or letter. The subsequent characters, letters, digits, underscore, not the exclamatory mark. In characters, only the underscore is accepted. And even here, same reason, so it is not considered. Now, identifiers may be any length, but compilers historically consider guaranteed to distinguish the end characters. Now, you can see here in C89 version, external identifiers were 6 characters significant, internal identifiers 31 characters, and this is for C89 version. And for C99 version, first 31 characters are significant. When it comes to internal, 63. C++, at least the first 1024 characters are significant. Now, why it matters? If two names differ only after implementation significant limit, they may be treated as the same identifier or an older compiler, and it is dangerous when porting a code. Now, an identifier, important point, an identifier cannot be a C keyword. Please note down this point. Keyword, it is a special name or a unique name we will be using in a program. For example, int for return. Identifier cannot be a C keyword. Avoid using the name that clash with standard library function names like printf. We will use printf to print the statements and scanf to give an input. But try to avoid this kind of words while stating a identifiers. Prefer meaningful names. Means to understand if you want to write a long program that's about 100 lines, you want know the each variables we'll be using. So preferably use meaningful names and starting names with an underscore followed by an uppercase letter or using leading underscore is reserved for implementation. It is please avoid this kind of things because it is reserved for compiler and for library use. Now the next concept is variables. Variables is a named location in memory that is used to hold a value that can be modified by the program. This is the definition of a variable. It is important. Please make a point, and all variables must be declared before they can be used. Okay, now let us see the declaration of variables. This is the declaration of variables. Type and variable list. That is nothing but type. We have already discussed the data types, right? Now let us take an example of int. Int is a type. Variable list means what are the variable you like to use in a program. It may be I or it may be a count, anything. This is how we will declare an, this is an example. This is how we will declare an variables. Now type must be valid data type plus any modifiers, and variable list may consist of one or more identifier names separated by commas. Now here you can see the example. Here int is a type ij1. These are variable list. Short int, it is a type. Unsigned int, double. The underlined words are in type and the remaining are variable list. Now here let us take this as an example. Here they have mentioned int I j1. We can write in this way also. Int I, int j, int 1. Even this is also acceptable and this is also acceptable. But to make it easier to write a code. For longer code, we can't sit and write this much, right? So to make it easier, we will go this form always. But make sure you use the commas while mentioning the variable list. That's what in this point I have given. Next, where variables are declared, like general declaration of variables we have already seen. But now, in a whole program, where variables are declared, it is declared in three places. The first one is inside function, definition of a function parameter, and outside of all functions. This positions corresponds to local variable, formal parameter, and global variables respectively. Now let us see one by one for how we will declare a variable for local variables, formal parameters, and for global variables. Let us see one by one. And the first one is local variable. I think it's the most accepted question in this chapter. So please be concentrate while listening to this and make a point. Okay. The first one is local variables. It are variables declared inside a function or a block of code. In some older C books, it is also called as atomic variables. Local variables was also called as atomic variables, but the most widely used name is local variable only. And it is used only inside the block and they cannot be accessed outside the block. All local variables come into existence when block starts executing. When it starts executing, it come into existence. When it ends, then it is destroyed. Now let us see with I'll explain these examples. First, let us see the points over here. Next, we will go to explanation of example. Furthermore, a variable declared within one code block has no relationship to the another block. Variables with the same name in different blocks are treated as completely separate variables. A code block in C defined as the part of the program starting with opening curly brace and ending with curly brace. A C language contains the keyword auto, which you can use to declare local variables. However, single non-global variables are by default assumed to be auto. So, while writing a program, we won't mention the word that is keyword auto. Now, let us understand with an example. While function 1 while here index is the local variable and here index is the local variable. Now, this point. A variable declared has no bearing relationship with the another variable. Here I have taken here see index. The variable name is different. Sorry, same, but the meaning is different. Here the value of x is 10, but here the value of x is minus 199. Here both blocks has no relationship over here. This is a different block and this is a different block. The local variable is valid when it starts, means opening a curly brace, and it's destroyed when we close the braces. Here x is equal to 10, it's over, that's it. When the next line executes, here the value of x is in the next block, the value of x will be x is equal to 199. Next, a variable may declare local variables within any code block. One code block is nothing but, now let us consider this is opening brace. I've written some code over here and this is closing brace. This is considered as one code block. Okay. Now, the block defined by a function is simply a special case. Now, for example, this is a function starts from here. Here, int is declared. Now scanf printed again block is another one block. Here when it comes to this block, if this is created only upon entering into this block, means the S character, this is declared when it enters if block. Do something means anything code, and when it comes here the block is over, means the completed one code block. Now when it comes to this place or this point, here as I said earlier, one code block is not known here. If you write yes here, it shows as error because it is not declared outside. Did you get my point? Yes. Now, when a variable declared within the inner block has the same name as variable declared by enclosing block, the variable in the inner block hides the variable in outer block. Let us see this point with an example. Now, let us understand with an example. This is a program example. Here, as I said, this is a one code block. Here, they have given two blocks. One is in outer block and again within this inner block. Means it is given in this way. Let me take it as this is an outer block and this is an inner block. Fine. Now, the value of x in outer block. The right mark one is outer block is 10. But the value inside the inner block is 99. So When let me first consider inner block and next we will go to outer block. Here, as I said, local variables is nothing but when a program executes means come to that point, it creates means the variable is created. Now here it came to inner block. Now index variable is created and here to print if inner x is equal to means we have to print value of x. So int x the variable is created and the value will be 99. That's the output we got. But as we close the braces, one code block is over, the value of x is equal to 99 is destroyed. When it comes outside, here in outer block, the value of x is 10. So this is considered and this is printed as output over here as outer x. I think you got this point. Okay, now let us move on to next. In C89 version, you must declare all local variables at the start of the block prior to any action. In the previous example, you have seen the creation of variables in between also, but in C89 version, we will declare all local variables at the start of the block. For example, now let us take this an example. This is an error like void f void int I declared and I is equal to 10. But again int j variables is declared and j is equal to 20. As I said in C89 version, all the variables must be declared at the first means prior to writing or assigning values to it. So this line will cause an error. Okay. Now in C99 and C++, local variables can be declared in anywhere. It is only this is only with respect to C89 version. Okay, clear with this? In C99 and C++, local variables can be declared anywhere. Anywhere in the program, in between also, if you need suddenly also, you can declare that and use it in C99 and C++ version. Okay. Local variables cannot retain their values between function calls because they are destroyed and recreated each time. Their content is lost. Okay, storage location. When it comes to storage location, by default, local variables are stored in a stack. Exception means the retention. You can force a local variable to retain its value between calls by using a static modifier. As we mentioned, all the modifiers we have a modifier static name. If we use this word while declaring it, we can retain its value. Okay. Now let us take another example. Here, local variables do not remember their values once function finishes. Each time you call the functions, they start fresh again. Now let us understand these 2 points with this example. Okay, now this is a for loop and f function. This is an f function. It is called how many times? 10 times. Okay, when it calls each time, the program is finished, again it starts in a fresh way. Means now if function is called j is equal to 10. Here local variable j is created every time. Now let us see here f function is called. Now 10 is printed. Now again it goes back to this j created one is destroyed means it disappears. As I said local variables when it curly braces. After the function calls means all the things over, it gets destroyed. Again a function is called. Again it prints 10. This again disappears. Again it comes back. Again it calls. And again it prints 10. In the same way it repeats, the output will be 10 times 10. Okay, this is all about the local variable and its declaration. Now, let us see about the formal parameters. If a function is to use arguments, it must declare variables that will accept the values of arguments. These variables are called as formal parameters of the function. From year to year definition, please make a point. They behave like any other local variable inside the function as shown in the following program fragment. Now let us understand with this example after the function name and inside parentheses means where formal parameters are declared here. Okay, int data type and the sim function name, and these are called as formal parameters. Formal parameters declared within a parenthesis. This is called as round brackets or called as parentheses. If though the formal parameters receives the value of arguments passed to the function, they otherwise acts like normal local variables. If you won't declare the variables in this parenthesis, means after the function, it thinks means the compiler thinks it as local variable. The next one is global variables. Global variables are nothing but we can use any way we want. Any piece of code, they will hold their value throughout the program execution. If I mention, let us assume we have a constant value. Let us take any constant value. For instance, I'll take a simple example. Now g is a 0.9. Have declared starting of the function in the program. If we are running or writing a code in 100th line also, you can use this value over there. Means here they will hold their value throughout the program execution. It won't get destroyed anywhere. Okay, when it comes to storage, are stored in a fixed region of memory allocated by the compiler and the lifetime. As I said, in entire program, we can use executing from start to finish. And why? What is the purpose of using this global variable? They are useful when many functions in your program need to use the same data. Right? Here, for example, here you will write one function. Here there is a need of g value. You will use this. Okay, you will declare and use this g value. But again, you need g value. But again, can't declare G value and go on writing, but it increases line. The code line also increases and the memory allocation also increases. So it is to avoid this situation, many functions, we will use this global variables. And what are disadvantages? Then what's the disadvantages? Why we have to avoid this global variables? If it is not necessary, so it's not a big program, we must avoid this global variables. Why? The first reason is memory use. They waste memory by exiting even when they are not needed. Right? Even let me assume this is a one program, three code blocks, and this is the main program. Yes, this is considered as one their inner block. Now, J is required here, J is required here, but it is not required here. But when we declare it is a global variable, here existing, it is a waste of memory usage. Okay, and the next point is reduce generality. Functions that they rely on global variables become less general, means less usable because they depend on something defined outside themselves. And the third reason is program errors or side effect. Using two globals can lead to error because of risk of unknown or unwanted side effects where a variable's values is accidentally changed elsewhere in the program. Okay, this is the main three reasons why global variables must be avoided in a program if it is not needed. Now you have seen about local variable and global variable. What if the both global variable and local variable name is same? Now let us understand this with this example. Here as include int count. Here now count is global. It is declared. Now there are totally two functions, function 1 and function 2. Okay, you can see here. This is a continuation of this program. Okay, I copy pasted the textbook part here. So it is looking like this. But this program remains the same, means a single program. Now count is declared in a global variable. Okay, inside the part count is equal to 100. Now function 1 is called. Okay, int temp is equal to count, and function 2 print count is and count. Now it will print 100 over here. As the function is called from this function, it prints 100. Okay, in second function, here again count is declared. Okay, but the difference is here the count is global variable, but here int count is declared within a single code block. Means this is considered as local variable. Okay, for count is equal to 1, count less than 10, count less plus. Here it is considered as local variable and here it is considered as global variable. That means we can conclude this if both the names are same inside the block, local variables is declared will refer to that local variable and no effect on the global variable. It does not means the local variable do not affect the value of global variable. Is that fine? Is that okay? Now I have explained all the concepts one by one, right? Now I have put it all the things in a single chart that is local variable, formal parameter and global parameter, and based on features I have differentiated among these three so it will be easier for you people to remember in your exams also and to understand the concept in a much better way also. Okay, I'll wait for a second. Please take a screenshot of this and do a practice. Take down. Okay. Now, the last concept for the day is the four C scopes. However, three broad categories are more finely subdivided by C, that is, four scopes that determines visibility of identifiers. These are summarized here. The four scopes means the C is defined here. The first scope is file scope. Starts at the beginning of the file also called as translation unit and ends with the file. It refers only to those identifiers declared outside of all functions. Now, file scope identifiers are visible throughout the entire file and variables that have file scope are global, right? The file thing is only larger one. Here, variables that have a file scope act like global one. Okay, and the second scope is block scope. Here, it begins with the curly brace and ends with curly brace. However, block scope also extends to function parameters and function definition. That is, function parameters are included in a function's block scope. Variables with block scope are local to their block. Okay, here it is considered as global and here it is considered as local to the log. And the third one is function prototype scope. Here, identifiers declared in function prototype means that means it is visible only to that prototype, means that particular prototype, not as globally. And the last scope is function scope. It begins with the opening curly brace and ends with a curly brace, but it applies only to labels. Here you might get confusion. That is here also same open closing. But here also same, but don't confuse here. Here you can see observe the remaining points also. Please take a look at it. Function scope applies only to labels, but it extends to function parameters. Okay, make a point here. Don't get confused. A label is used as the target of a go-to statement, and that label must be within the same function as the go-to. This is all about the four C scopes. So that's all for today video guys. But wait, as the chapter 3 is like huge concepts are there, I have created two videos, means I have divided into two parts. This is all about part 1 concept. Next, please go and watch the part 2 video also. The remaining concept will be covered in a part 2 video. So stay tuned. So if you find this video helpful, don't forget to like the video, share it with your friends so they will get helpful and subscribe to Explore Electronics for more such concept. See you in the next video. Thank you guys. Bye.